Lesson 92 and 94 talk about uniform motion problems. Those go back to when we did the problems with distances. And if you remember, distance equals the rate times time. So in these problems, we are going to have we have to write down our equations and then fill in as much as we know. So for example, in lesson 92, the problems will be something like this. On Tuesday, the express train, which I'm going to represent by E, made a trip in 12 hours. And the freight train on Wednesday made the same trip in 16 hours. They want us to find the rate of the express train, which I will write R with a little e, and they also want us to find the rate of the freight train. They do give us one more piece, one more set of information. They say that the rate of the freight train was 15 kilometers per hour less than the rate of the express train. So the way we'd write that, let's see how, we have to figure out how we would write that. We want to write that the rate of the freight train equals the rate of the express train minus 15 kilometers per hour. This shows us that the express rate is higher, greater than the rate of the freight train. So we know we set this up correctly. Now we have all this information. What can we do with it? How are we going to be able to find the rate of the express and the rate of the freight? Well, first of all, we want to write down two distance problems. We want to write down the distance of the express train equals the rate of the express train times the time of the express train. We can write another distance equation for the freight train. The distance of the freight train equals the rate of the freight train times the time of the freight train. Now, if we look at this, we can see in this problem, the express train and the freight train made the same trip, just on different days. So we know that the distance of the express train is equal. They made the same trip. So the distance of the express train is equal to the distance of the freight train. If this is equal to this, then that means that this would be equal to this, because we can substitute our RETE in for DE, and we can substitute our FTF in for DF. So when we write that equation, we see that we end up with 4 different variables. There's 1, 2, 3, 4 different variables. We cannot solve an equation until we have only one variable. So we need to use all this information that we found up here to plug into this equation right here. So what I mean by that is we're going to keep the rate of the express train. That's the only variable that we're going to allow in this new equation is the RE. Because we know the time of the express train. They told us that the time of the express train is 12 hours. So we're going to multiply that by 12. Now, the rate of the freight train, we don't want to write RF because that would make 2 different variables in this equation, an RE and an RF. We only want REs. But if we look up here, we see that the rate of the freight train is equal to the rate of the express train minus 15. So we can take this expression right here and substitute it for the rate of the freight train because they're equal. So right here, we're going to, instead of writing RF, we're going to write the rate of the express minus 15. Now we have another variable that we need to find a number for. It's the time of the freight train. The time of the freight train is 16 hours. Now that we have this new equation with only one variable, we can solve it. So we're going to rewrite RE12 as 12RE, just easier to work with. We're going to use the distributive property and write 16RE minus 16 times 15 is 240. We're going to add 240 to each side, and we're going to subtract 12RE from both sides, giving us a new equation of 240 equals 16RE minus 12RE is 4RE. Now, if we divide each side by 4, these 4 cross out, leaving us with the rate of the express train equals 240 divided by 40, which is 60. Now we know the rate of the express train is 60 kilometers per hour. If you recall, the rate of the freight train is 15 kilometers per hour less than that. So we know then that the rate of the freight train is 45 kilometers per hour. So that's how you find the answer to these type of problems. You have to write down the equations and then plug in what you know getting it to an equation that has only one variable. So we're going to do another one. This one will be from lesson 94. This type of problem is from lesson 92. Lesson 94 also talks about distance problems, but they have a bit of a twist. And these problems, we kind of want to draw a little picture to help us make sure that we're understanding the distance. For example, in this one it says, a train starts from Toledo at 11 a.m. and heads for Mackinac, which is 332 kilometers away. Okay, so that's going to be our distance. At the same time, a train leaves Mackinac and heads for Toledo at 65 kilometers per hour. If the trains meet at 1 p.m., what is the rate of the first train? That sounds very confusing. There's a lot of information in there, and it could be that you feel like, oh my goodness, where do I start? Well, the best way to start is to first draw a little diagram so you can picture what we're looking at. We're going to make this line stand for Toledo. This is where Toledo starts. The train from Toledo starts. And we're going to make this line the line of the Mackinac train. So at 11 a.m., this Toledo train starts heading this way. And then the train for Mackinac heads towards Toledo from this way. They are going to meet, it says, at 1 p.m. So they meet somewhere in the middle. How does this help us? First, we're going to go ahead and write down our two distance problems. We have the distance of the Toledo train equals the rate of the Toledo train times the time of the Toledo train. The distance of the Mackinac train equals the rate of the Mackinac train times the time of the Mackinac train. Okay, so what else do we know? We know that the Toledo train left at 11 and met at 1. So from 11 a.m. until 1 p.m. is 2 hours. So the time of the Toledo train equals 2 hours. We also know, it says in here, that the Mackinac train left at the same time. It left at Mackinac and met at 1 p.m. So the time of the Mackinac train is also 2 hours, which is convenient. What else do we know? It also tells us that the rate of the Toledo train was 65 kilometers per hour. So we're going to go ahead and write the rate of the Toledo train is 65 kilometers per hour. We do know another piece of information. It says that the distance between Toledo and Mackinac was 332. So we can write that as the distance that the Toledo train went plus, so the Toledo train went from here to here, plus the distance that the Mackinac train went, that's from here to here, equals this total, which is 332. All right, so now we have all the information we need to put this together. Well, how do we do that? Well, we're going to take and rewrite the distance of Toledo. Since it's equal to RTTT, we're going to write it like that. The rate of the train of Toledo times the time of the Toledo train is substituted in for this DT. And now we're going to substitute the rate of the Mackinac train and the time of the Mackinac train for this distance, because the distance of the Mackinac train equals RM times TM. And we're going to leave it at 332. Now, just as the same thing with the last problem, right now we have 4 different variables. If you recall, we have to only have one variable in order to solve this problem. So let's start plugging some things in here. We know that the rate of the Toledo train is 65, so we can put that in. We need to multiply that by the time of the Toledo train, which is 2, so we can put that in. We're going to add that to the rate of the Mackinac train, which we don't know that, so we're going to leave RM alone. But we do know the time of the Mackinac train, it is also 2. Now we have an equation right here that only has one variable, just the RM. When we get to this point, then we can solve it. 65 times 2 is 130 plus 2RM equals 332. We're going to subtract 130 from each side, which gives us 2. RM equals 202. And when you divide that each side by 2, that gives us the rate of the Mackinac train is 101 kilometers per hour. And that's the only thing left that we had to solve. They wanted to know what the rate of the Mackinac train was. So when you do these problems, it's important to write down these first equations. Write down the 2 distance equations, the distance of one of the vehicles, whether it's a train or a plane or whatever it is, and then write down the same type of formula, distance formula, for the other one. Then figure out what else you know that was given in the problem, drawing a diagram if that helps, and then you start substituting until you only have one variable. When you have one variable, then you solve it, and once you get one piece of the puzzle, you can go back and find all the rest of the pieces of the puzzle.